Okay, here's an example of using the dot product again to project one vector onto another one. Now, basically in this case, I think I'm gonna have to draw a little object here. All right, I made this problem up. Let's just say we're pulling an object across the ground here. Okay, but usually, you know, if we're really tall, you know, your arm hangs down here. And let's say we have a rock on a string here, and I'm just pulling it on the ground. Okay, well, I'm applying a force to it. Okay, and if I'm applying a force to it, then but it's traveling in a different direction than the direction of the force I'm applying to it. Okay, so basically we're asking ourselves how much of this force that I'm applying in this direction is going to make it in this direction. Or, you know, I could word it a little different. I could say I want to apply this much force in this direction. Okay, now notice, you know, we know that from trigonometry, you know, we can find this height and this distance right here, but we don't know the angle. Okay, let's just say we didn't have a protractor on the day that we decided to tote rocks through the desert. Well, I mean, it wouldn't be. Well, let's just, you know, it's just an example. Okay, so let's just do it. So basically, here's our formula over here, and if we wanted this is what we're after. So if we wanted f cosine theta, what we'd have to do is just divide both sides by magnitude of d. So we need dot product of f and d, and then we need to find the magnitude of just, you know, d, or direction. Okay, so let's go ahead and do that and see if we can't get some damage going. So first of all, let's go f, and we'll dot it with d, and that's going to equal what is it, 84 plus 0. Okay. Alright, it's 84. That was easy. Magnitude of d, that's going to be 12 squared, is 144. Square root of 144 is just back to 12. Okay. And that should make sense too, because it doesn't have a horizontal component. So anytime, you know, there's only one component here, the magnitude is going to be the value of the single component. Okay. All right, so there we go. So let's just, if we divide these, we get 84 divided by 12, which equals 7. Okay, so it looks like 7 pounds of force make it that way. All right, now let's just check and see if this seems logical. Okay, let's take the magnitude of f. Okay, and so this magnitude should be less than this one. Okay, I mean, because not all the force is going to make it into a horizontal state. Okay, all right, so magnitude of f, that's what, 49 plus 16, that is 50 plus 15 equals square root of 65. If it was square root of 64, it would be 8, so it's going to be a little bit bigger than 8. Let's just call it 8.1. You know, I don't know exactly what it is, but we'll just say it's 8.1. It seems like a logical answer, though, doesn't it? Because if I applied 8 pounds this way, and only 7 of it made it horizontally. So yeah, I like it. You know, sounds pretty good to me. So yada yada. There we go. So that's pretty much an application right there. And like I said, you know, we're just kind of doing refreshers. I'm not going too deep into some of this stuff unless you want me to. I mean, if I get like comments that say, hey Chuck, do more dot product stuff, I will do more dot product stuff, but I'm trying to truck on and get to vector calculus. Okay, so I will see you when we get to vector calculus, or when we get to the cross product.